Yeah, my name is Hindrik de Vries. Who we are from SALD, and we are an original equipment manufacturer, actually leading the industrialization of spatial atomic layer deposition in solar. We have more than 15 years of experience in building, designing equipment for spatial atomic layer deposition. Yeah, we're also located in Eindhoven, Netherlands. And our main target, main objective is to develop dedicated R&D and high volume sheet-to-sheet and roll-to-roll tools on customer demand. And these are some of the tools we built, and the last one is an envisioned roll-to-roll setup. And well, this is our latest project where we are building a large spatial ALD tool for the processing of aluminum oxide, tin oxide on large glass plates. Sold around the world, we have already installed quite some tools in the world. So from the United States, Europe, also Asia, and also now in Germany we have a tool installed. So that's very nice. All for perovskites basically. So that's interesting. We came from the passivation, silicon passivation by aluminum oxide, but now we see there's a lot of traction into perovskite, and that's our main market at the moment. So. And one of the interesting applications is, of course, roll-to-roll. And today I want to discuss more in detail about roll-to-roll spatial atomic layer deposition. Well, let me see. So application could be indeed perovskite, but also moisture barriers, which are essential also for encapsulation of perovskites. But we're also looking into membranes, electrolyzers, and batteries. Those applications all have in common that they are energy-related applications and require large areas and high volume, basically. And well, some of the projects we are participating in are mentioned in at the bottom. Yeah, perovskites and moisture barriers, and that's basically also what I want to show some results on. Why roll-to-roll? Well, I have a background I worked at Fujifilm for quite some years, and at the production site of Fujifilm in the Netherlands, they produce photographic paper. Still produce a lot of photographic paper, and the photographic paper consists of 8 layers, different functional layers, which are coated in one time, basically. So that's they do it by using slot-die coating. Slide coating, I must say. It's not slot-die, it's a slide coating. So the die, which they call a geyser actually, so they place in close proximity with the coating roller, and then the web is transported over a robust, very stable roll, and then they slide the coating, and then they get a very accurate coating on top of the photographic paper. So it's a one-step coating, but they can do this at very high speeds. So 300 meters per minute, day and night, 24/7. So imagine if we can do that also with perovskites. And I show here a very simplistic picture of a perovskite cross-section, but suppose if we can grow, maybe coat those layers at 1 meter per second, and we have a 20% efficient solar cell, and we can do it at 1 meter or whatever, then we can maybe make 5 gigawatt of power per year. That's really amazing. So if we can run at 1 meter per second, we can really make a difference here. And I will focus in my presentation mainly on some interlayers which can be deposited by ALD, and that's the aluminum oxide, nickel oxide. I will show some first results, and also tin oxide. Yeah, okay. It's a high-speed enabling process, and I think that could be very important for the success of perovskite solar cells. Now, spatial ALD, that consists of two half reactions of a precursor and an oxidizer.